Hey folks, my name's Chuck Black. We are doing 52 weeks of Python and we are in week number 34. And the topic for this week is Pyshark. Pyshark is a wrapper that goes around packet capture capabilities on your system. In this case, they're mentioning TShark. Packet capture, what is that? Well, we do something like that in Quokka where you can request packets get captured for a particular IP address or protocol or port or something of that nature. We'll retrieve those packets and print them out. Now, as it turns out, in Quokka, I do not use Pyshark in order to do it, but instead I use Scapy, and so that's just what I chose to do. I could just as easily use Pyshark. It is popular. It does continue to get updated, so it's a viable potential solution for what you might want to do. Now, I mentioned filtering packets. There's something called a BPF filter, Berkeley Packet Filter, and that allows you to specify the packets that you're looking for. You can look by IP address or protocol, or you could do it via port or what have you, and that's kind of what we do in the examples that I give you. In fact, it's exactly what we do in the examples that I give you. We look at setting up a capture by calling this function live capture. There is live capture as well as file capture, but we'll look at live capture only. You create a capture and then you can do sniff. You can pass in your filters. In addition to doing sniff, you can get packets one at a time and call a function that's apply on packets. You can also do sniff continuously. That returns a generator so that you can immediately do a loop. And lastly, we have a function which allows the user, that'd be you, to input your own BPF filter, and we will attempt to capture packets that match that. And just because you may type in the filter wrong, I put a try except clause around it so that you can do Control-C and continue and re-enter the correct filter. So that is what we will be talking about. So without further ado, let's get started. All right, so let's talk about Pyshark. What is Pyshark? Well, in its own words, Pyshark is a wrapper for TShark. And then you might say, well, what is TShark? TShark is the thing that is implemented at the lower level that gives us all the Wireshark stuff. If you're interested in Wireshark, you can go over here and find information about it. You can do any of these trainings, look at videos, read stuff, etc. Wireshark basically allows you to see stuff like this, where you capture packets and it breaks them up into their constituent parts, and you can examine that and learn more about it. Now, what I'm going to do and what I've done is I've written code that allows us to do packet capture using Pyshark and to display stuff appropriately. You'll see that it's fairly similar to what I've done already with Scapy. We do packet capture with Scapy. In fact, in Quokka, which I just got rid of, but the packet capture stuff that we were looking at, I actually use Scapy to do my packet capture, not Pyshark. Perhaps as a learning example, maybe I should have used Pyshark instead. Maybe I'll change that at some point in time. But for right now, I'm using Scapy. But that's not the topic of our lesson. Our lesson today is to look at packet capture with Pyshark. Now that you know in general what that is, let's look at the code. Okay, so let's look at the code that we have here in the Pyshark example to demonstrate packet sniffing with Pyshark. Remember, it's just for sniffing packets. It doesn't even save into a PCAP file. It's just for sniffing packets that have either been captured and you can read a file, or you can do a live capture. And in the examples that I have here, I'm doing a live capture, so we'll see that. So we had to install it. I've imported it here. I defined a little function for printing stuff up, so just let's take a moment and look at this so you don't get confused if you're new. All I'm doing, I'm taking the packet that I've been given by Pyshark, and I am performing a string function. So Pyshark has implemented their packet object in such a way that if I try to print it out, it prints a nice output, and so that's good. But when I'm printing a summary, quite often they'll end up being 160 or more characters, which ends up wrapping on my terminal screen, and there's not an easy way in terminal screens to truncate that, and so it ends up looking messy. So what I did is I implemented this print packet summary. You'll also notice that I use this as an important function to be called when we're dealing with packets as they come in, and you'll understand that more later. But anyway, str packet changes the packet into that string that we need, and then what I'm doing is this. Let's see if I give you a second to think about what that might be. The correct term for this is slicing, and this is what you can do with strings. And basically with this colon in here, on the left hand side of the colon, which would be right there, you specify the starting point. If you don't provide anything, then it starts at 0. Over here on the right hand side, you specify the ending point. So I'm getting just what's called a slice, or like a substring, but I'm not doing it via a search. I'm just arbitrarily saying I want you to go up to 120 characters and no more. And if we were to look at the output from that, if I find the right screen here, you can see I've kind of trimmed my the output so that it stops before it gets to the end. So that's all that I'm doing there, so that it ends up, we can see all the packets. All right, let's go back to the code. I have this function called print packet summary. Let's look at how we do Pyshark. And if you recall from Scapy, all we really needed to do with our Scapy example is we needed to just say, here, let me go to the beginning. All we needed to do was say sniff, and we passed it the interface and the count and stuff. In Pyshark, we do it a little bit different. And first thing that we do is we create this live capture object, and we're going to be calling that capture. And in that, we pass in the interface and other parameters that we can do, such as filters. And in this situation, I'm saying only summaries. That means make sure my packets are just like one-liner packet summaries. And I've set that to true in this situation. So once I've done that, it doesn't actually start to capture until I tell it to start to sniff by saying capture.sniff. So I call this method on the capture object that has been created, and I pass in how many packets I want it to get. Now you can also specify a timeout. I had different amounts of success with attempting to do timeout, so I've done just packet count equals 10 in all these situations. If you use this yourself, you can experiment with having it listen for a certain amount of time. And if you recall from Scapy, in Quokka, I do listen for, I think, 3 minutes was what we decided. So yeah, but here I'm doing just the count. I'm waiting till I get 10. So that means we're going to wait around until we get 10. And once we're done, another nice thing about this capture object is it is iterable. And I'm not going to go into how it gets implemented in that manner, but I can iterate through this capture object, and it will give me a packet at a time. So this is really quite handy for dealing with it. And all I do is I say for every packet that you've got, there should be 10 of them. I want you to print packet summary. Remember, that's this function right here. And if we look back at the output, and if I was to go to the very top of this, then you can see here's my packet summaries. It's printing them out. My summaries, it gives me the number of them, meaning the index, the order, 1, 2, 3, 4, 5, etc. And then it gives me this information about the packet, so I can see what was going on when I did this. For whatever reason, it's got these Google Cast, and I haven't even taken any time to try to figure out what this is. But there you go. That is the first packet capture. Now you'll notice all we did was we listened on the interface and we got all packets. What if you want to get only specific packets? Well, you actually have two options. So let's look down here at this code. Now this code is going to look almost identical to this code right here. The only difference I can tell you is what I added right here, which is the filter. Now there are two types of filter that you can use. One type is called the display filter, and that allows you to specify things at a higher level, like DNS, just the actual string. But if you do a PF filter. That stands for Berkeley Packet Filter, so it's a little bit redundant, but it is a format for passing down into the bowels of TShark and the packet capture and low-level stuff, and it knows how to deal with information such as this. It knows you're specifying the UDP protocol, and we're looking for a specific port, and in this situation, we're looking for port 53. So this will be giving us DNS packets only because UDP port 53 is DNS. If I go back to my output, my DNS packet summaries, what we should see here as it prints them out is that, yeah, it does appear that these are all DNS packets that it found for various reasons. Let's see, this one was between 254, that's my router, and 158. Looks like this particular point in time that I got this, they were all communications between those two. So DNS, my DNS server, local DNS server, is apparently configured to be my gateway, and so that's where I am sending these requests. So that is the DNS part, all right? That's pretty straightforward, these two things right here. Now the next one is where we're just going to say, notice the difference here is we're not saying only summaries equals true. I'm leaving that off. That means I'm getting all packets. Also, sorry, I'm getting the full complete packet. Also, I don't have a filter specified down here. You can see I'm just specifying the interface, so it's going to get everything. And now when I go through and iterate through, notice here, I was saying print packet summary because I wanted to trim it and do it in a special way. In this situation, I am just saying print packet, and so the capabilities that are within Pyshark, this capture object, are able to print it out. What does it look like? Well, the good news is it looks like you would hope it would look. Here's a packet. Its length is 42. There's the Ethernet layer, so there's layer 2 up, and I can see that this is an ARP request, so this has broken out all of the ARP information for me. That's kind of nice. Here is another one. The length is 218. Ethernet, you can see the destination. It's a broadcast packet. Don't know what this particular one is. I ran this, and let's see, my source port is in this high userish range, as my destination is all 6s. Not sure what that one is. Let's take a look and see if we can find one that looks, here's an ICMP packet. So somebody seems to be doing an echo request. Here is another ICMP. Here is a TCP packet for these two ports, 5970 and port 5228. I'm not even sure what that is at this moment in time, but you're getting the idea. You have all of these packets, and there are going to be roughly 10 of them that we print out. So same thing as the other ones, but we're just we're just capturing the entire packet, and we're printing that out. Now, let's look at a couple different ways to do things. So as you can see from the comment, capture and handle HTTPS packets as they arrive. So let's look at my live capture. What am I saying? My interface is the same, of course. Only summaries is true, so I'm just getting the summary. And my BPF filter is HTTPS. So now I've set up my live capture. But remember what I did before was I said sniff. I'm not doing sniff this time. I'm doing apply on packets. So basically, this is telling Pyshark, hey, I want you to go and begin to do this capture, but for every packet that you get, I want you to call this function. So what is this? What is this right here? Well, remember, I defined it up here, print packet summary. That's the name of the function. If you remember from SCAPI, was it SCAPI that we did PRN? I can't remember. We had a parameter that we passed in to do something similar to this. But here I'm doing my packet count equals 10, print packet summary. And if we look at the output, once I get past all of these packets, here we are, print packets as they are detected, and it's printing these packets out. And Yeah, so these were all, remember I was capturing port 443 were the ones that I was looking for. And so some of these say 443, some of them don't, and I'm not 100% sure why. I suspect that it's because it's a TLS v1 or TLS v2, which is the S part of HTTPS, but that's what we're doing in this situation. So I don't have enough expertise in digging into these because I haven't done it in a while to tell you exactly why we're getting all of these, but that is what the Berkeley packet filter gave us in this situation. So that is how we do Pyshark in that situation. Now, the second thing that I'm going to show you that has to do with apply on packets is going to be, instead of giving the name of a function, I can provide the function right here. And remember, we did this for Scapy as well. Lambda, which I haven't talked about, is just it's basically a one statement function. And what this is going to do, let's sort of parse this. I say Lambda, so Pyshark knows that it is going to be a Lambda function. I'm thinking right now in the back of my mind, did I say PyCharm when I meant to say Pyshark at one point in time? If I did, my apologies. Pyshark is aware of the fact that this is going to be a Lambda function. This thing right here is the parameter that gets passed to the function. That is going to be the packet that we received. Okay, that's just how apply on packets works. And then the name of the functionality is going to be this thing right here. Now, what I'm doing is it's a single print statement. I'm printing out the word Lambda, a bunch of spaces, and then I'm doing this string of packet, and I'm only printing 114. I thought I'd be cute because I thought that these 6 characters Lambda would cause it to line up correctly with the other stuff. Let's see if it did, and I don't think that I did a very good job of that because it's offset a bit, but you can get the idea. This is kind of what, oh no, I think that what I was doing is I wanted to trim it, and so you'll notice here on the right, yes, I did trim it successfully, so I guess I'm not as stupid as I thought, at least not on this evidence alone. I suspect that many other people, including David Bumble and my wife and my kids, would disagree with the fact that I'm not stupid, but I digress. Here's my Lambda. There we go. All right, this is my apply on packets. Now the next thing is a different function that we can call entirely. This one is called Sniff continuously. And so what this does, it allows me not to have to do something like this, where I do a capture.sniff and then I do a for loop. What this does is it's going to return a generator. Now, we talked a little bit about generators. The basic idea is it returns one thing at a time, so it's good for iterating. So what this is going to do is it's going to allow me, with a smaller number of lines of code, to do effectively the same thing that I was doing before, except by using this sniff continuously. I don't have to have a separate statement that captures the capture and then does a for loop with it. So that is what sniff continuously does. Again, it will sniff forever. I suspect it will sniff forever unless you give it a packet count or a timeout. I don't know if there's a default, but you know what? I don't know the answer to that, so there may be a default just to protect people from doing something that they shouldn't. So again, I'm doing the packet count. All right, so that is the first part. Next, we're going to examine this last piece that I wrote. But hey, before we go to the next part, I do want to show you this running. So let me start it. You'll notice that I'm not running it within PyCharm. That's because it needs to run as super user or root, and so I need to do sudo and run it here. So here we are. That's the name of my program. I'm going to run it. It's getting its packet summaries. Remember, it was collecting all packets, and so that is what it does right there. Now the next you'll see DNS packet summaries. It's waiting for 10 of them to be received, but unfortunately I'm not really doing DNS. That's why I've got this up here so that we can actually redo this, and you'll notice, okay, well I got my DNS stuff, so that's all good. And you can see that if I were to scroll up, here's where I got all the different packets. They'll be different this time, of course, than they were before. There are 10 of them, but it takes a while to scroll through them. Here's my DNS packet summaries, all of my DNS packets. Here's my full packets. This one is TCP port 443, so this one is going to be getting HTTPS type stuff. And here's another one where I again am doing port 443. And let's see, here's another one, Ethernet, IP, TCP 443. So I'm getting a lot of data. Maybe it was related to this BBC News page that I had up and going. And so yeah, so that's all of that stuff. And then once I get down to the bottom here, this printing the packets as they are detected, I probably didn't do a very good job of having us watch that happen, maybe because packets were coming in, but they're getting printed out, you know, slowly one at a time. And then this is the Lambda version of the same thing. So instead of waiting till we got all 10 of them, it printed them out one at a time. That was the result of doing apply on packets. And then also I did sniff continuously at the end. And let's go and look at, here's my print packets as they arrive with sniff continuously. Okay, so that is what it is. This next thing, you can kind of see that I'm waiting for user input. So let's, before we do that, let's look at the code that actually implements that. So here is my code that implements this. Now we've done things like this before where we got input from the user, so there's nothing really new there. The difference in our situation is I'm asking the user to enter a BPF filter, so that is going to be received. If the user hits enter, then we're going to quit. If they don't hit enter, then we're going to go in and we're going to begin to do this live capture thing, and that is where we're going to sit and capture packets that meet this interface, only summaries equal true, and BPF filter that I just provided. Now it's not going to sit here. I spoke incorrectly. What's going to happen is we're setting up this capture object, and then we go and we call the method apply on packets, and then we print them out one at a time as they are received. And now what I've done, one extra thing that I've done, is I've put this in a try except clause. And the reason for doing that is I found that it was not unusual for me to mistype what my BPF filter was. And if you do that, then quite easily you can end up waiting forever for something to happen that's never going to happen. So I allow myself to do Control-C, and I'll go back and get the input again. So let's take a look at what that actually looks like when we're running it. So I'm going to say, oh, and by the way, let's see if I have this. Yeah, so here is, you can just look up BPF syntax or BPS stuff, and you can find lots of examples of how you can do it. You can say IP host host. I can also just say host. You can specify TCP source port or TCP port. I can specify lengths. I can do IPv6 stuff. There's a lot of resources that you can get that will help you to figure out what is legal to type in. So I'm going to type in 192.168.254.14. That's the IP address of my local laptop. Now here you can see it was printing those out as they came in, and it did print them out. So that's nice. What if I was to say source host 192.168.254.14? see if I typed that correctly. So now I should only see the ones with 192, 168, 254, 14 as the source. And that is indeed what has happened here. So that's good. What if I point to, I think I have a Google, I always try to do the up arrow, which I don't even know how to implement. I've never looked into that, so I probably should. I'm going to do 192.168.254.10. I think that's one of my Google devices. Now, that Google device is just sitting in the network. I suspect, I don't know what Google device it is. I could try talking to it, but probably an easier thing for me to do would be to just ping it. So why don't I ping it here? Why don't I move this up over here? So it's a little bit easier to see. So I'm going to go ahead and ping this. And what you should see is you see down here, we're starting to get packets as it does the pinging. So I can stop that pinging, but you can see I could probably filter on ICMP, and I'm not exactly sure how to do that, so I'm not going to do that right now. I could filter on TCP port. Let me go down here and do it where I'm supposed to be doing it. TCP port 443, and now it's capturing all port 443. There seems to be a lot of stuff going on. I didn't even have to do anything special. Let's see if we can do TCP port. Like, what if I did 442 by mistake in my code? I have no idea what 442 is or might be, but I don't know how to generate that, so I'm going to hit Control-C, see if my code still works. So I hit Control-C there, and I get to try again. TCP port, what was I going to do? Port 80. I was going to try port 80. Now, most things don't do port 80, and I find it somewhat hard to generate port 80 requests. Let's see, how did I, maybe here I'll end up with some port 80. Everybody's doing port 443. Let's see. I guess I could do, what if I do localhost this? I don't have my Quokka running. Let me go back and look and see, am I doing this? I'm applying on packets, so, oh hey, guess what? I got a bunch of them. How did I get them? I have no idea, but somebody did port 80 stuff. Let's see, 158 and 32. So I should find out what 30, oh wait, that's 34, 112, 121, 32. You guys can probably go try to find out, do an NS lookup and find out what host that is. I don't even know what it is. Anyway, there, you get the idea. I hit enter and it ends. And so that is my Pyshark code. Now, I haven't done live capture. You can look up. Doing file capture is exactly the same. The only difference is you point to a file and it does it from a file rather than from an interface. So if you have Wireshark captures and you wanted to do that, it's fundamentally the same thing. Okay, so let's review what we talked about. We were talking about Pyshark. Pyshark is itself a wrapper for TShark. TShark is the thing that does packet captures at low levels on your system, and so Pyshark provides a way to get access to that. One of the ways that it does that is through using filters, and we looked at various ways to do these things that are called Berkeley packet filters. You can also do display filters as well. Now, how are those used? Well, for example, packet capture is used in Quokka to provide information about packets that are seen that meet certain criteria on the network. Now, Quokka does not use Pyshark. It uses SCAPI in order to do packet capture instead, but it could. And so that is the general domain about what we're talking. Now, let's look at the code and review what we did. Going to the top, we imported Pyshark. The way you use Pyshark is you set up a live capture, which gives you a capture object specifying certain information such as whether you want only summaries, what you want the BPF or display filter to be. Then you say sniff, and that will wait until you've received the appropriate number of packets or till a timeout, if you specify that, is exceeded. And here we just go through and we print out summaries of the packets. So here's another example where we're using the filter. You can also get complete packets. So if you don't specify only summaries, then it will give you complete packets. You can handle packets as they arrive by setting up the live capture in the exact same way, but instead of doing sniff, you do apply on packets, and you can specify the function that you want to be called whenever a packet is received. In our case, we just printed it out using this fancy thing that I described in there. Or you can specify your own function inside using Lambda capabilities. So here I'm doing Lambda in order to do that. One last thing you can use, instead of doing sniff or applying packets, you can directly put into a for loop your captures and handle them one at a time by using sniff continuously. That returns a generator, and the generator allows you to iterate for every packet that is received. Now the last thing that we did was we have this little while loop that just allows you, the user, to enter the BPF filter, and then it applies that BPF filter when it does its live capture and then does apply in packets and prints it out. And we mentioned that we use this try except clause so that the user can hit a Control-C and end up with us popping out and then going and getting the next BPF filter. So that's what it is. Hopefully this Pyshark definition has been useful to you and will be helpful to you if you choose to use it as you go forward in your Python programming endeavors. Thanks for listening.